Okay, good day to everyone. Today our lesson is talking about application of arithmetic and geometric series. So the learning outcome for today is at the end of this unit, students should be able to apply the concept of arithmetic and geometric series in solving problems. So let's see the example number 18 here. Determine whether each situation describes an arithmetic or geometric sequence. Give your reason. A, the price of a new car is 42,000 ringgit Malaysia. The value of the car depreciates at a rate of 10% each year. Okay, so look into this question. You have to know that the price of the car is 42,000, but it depreciates mean that it's going down and getting cheaper each year for 10% each year. Okay, think about it is whether they are arithmetic or geometric. It's getting less each year for 10%. So question B, in a race, a long distance runner took 3 minutes 45 seconds to run the first kilometer, and in each succeeding kilometer, 12 seconds more than the preceding kilometer. It also means that it's getting, they need more time each 12 seconds more than the preceding. So means that this runner took longer time to run every 1 kilometer. Maybe this runner getting tired. And so what do you think? They are arithmetic or geometric? And a farmer has 300 cows. He sold 12 cows on the first weekend, and for following weeks, he sold 5 cows more than the week before. Okay, I would like to give you 30 seconds to think about what is the answer for these 3 questions. Is the arithmetic or geometric sequence? Okay, you focus into the patterns of this question. Okay, so let's see the answer here. So for the first question, A, geometric sequence because the decrement of the value is depending on the preceding terms. Okay, so the answer that you get, let's say the 42,000 is going to divide by 10%, you are going to reduce 10% from the overall total balance. As for question B, arithmetic sequence because the increment of the value is fixed. Okay, the keywords here is a fixed over consecutive term. They are fixed. Okay, so next one, as for question C, arithmetic sequence because the increment of the value is fixed over consecutive term also. Okay, so this is the answer for these 3 questions. Moving forward to example number 9. In an examination, Bill took 60 seconds to answer the first question. The amount of the time he spent on answering the next questions increases 30 seconds from the previous question. If there are 50 questions to be answered within 1 hour 15 minutes, does Bill manage to finish answer all the questions? Okay, so as this question, I have the solution as in the first one is 60, second one is 90, then the third one is 120, 150. So you can see from here to here is increasing 30 seconds. Add on keep second. Okay, so the question actually asks you if for 50 questions, is that enough within 1 hour 15 minutes? Okay, all right, think about it. What method, what strategy should you use to answer this question? Okay, so if you have the strategy, let's see whether the strategy is same as this one. Okay, so from here we can get the idea as this one is the A because this is the first value, and then the D is the difference between each term, and then N is the number of term. Okay, number of term. So we put into this formula. So the amount of time to answer 15 questions is this one, N over 2, 2 times A plus 14 times 30. So it's 4,050 seconds. You convert them into hour and minutes. So you found out that since the duration of the examination is 1 hour and 50 minutes, Bill will be able to finish answer all the questions. Okay, so we are using the sum of all this question formula to answer this question, okay? Right? So make sure you use the right formula, okay? Okay, we move forwards to example 20. A walkathon, walking marathon, or sponsored walk is a type of community of or school fundraiser in which participants raise money by collecting donations for walking a predetermined distance or course. Suppose Harry joins the walkathon for his school alumni. In the first hour, he walked 3 kilometers. In the second hour, he walked for 2 kilometers in each succeeding hour. He walked 2/3 of the distance the hour before. How far would Harry's walks in 10 hours? Okay, 10 hours cannot, how far? So you can look into there are 3 hours and then 2 hours and getting less and less and less. So within 10 hours, how far he can walk? How far would Harry walk if he keep on like this forever? What do they mean by keep on this forever? It means that you can see from 3 become 2 is actually 2 is 2/3 of up here, and then getting less and less and less. Okay, so what kind of formula you are going to use to solve this question? Okay, right, let's see this one. So the solution for this one is for first one, in 10 hours Harry will walk for, so the sum of 10 hours within the whole entire 10 hours, how far he can walk, as if we use this formula. So 3 and then 1 minus this one, r, okay, is power of 10. Why we use this formula? Because this r is less than 1, okay? It's less than 1, so we use this formula. So the answer is 8.8439 km, okay? But if he walk this one as in infinity, like forever, just for this example, okay, you use 3/1 minus r, you get 9 kilometers. So if you walk forever, he total up, he just get with this formula, he only can walk at 9 kilometers. Okay, 9 kilometers. Now, let's see, we try to solve this question. Okay, PSS2 question. All right, so a company borrow 5,000 from a bank. The loan is repaid by 20 equal yearly installment. So look into this data, 5,000 from a bank, 20 equal yearly installment. The first payment being made for the year after the loan was taken if the interest charged on the loan is 5% each year. Find the amount to be paid each year. Okay, so let's see this one. Let P n be the debt after n years and x amount be paid each year. Okay, so as for this one, you can see the first year, the beginning, from the beginning we use PO is 5,000. Then P1 is equal to 5,000 plus 5% multiply with this one original amount minus x. X is the unknown. The unknown for what? For amount to be paid each year. We're not sure what is this. Okay, so we create a formula like this, and then it's equal to 1.05 P1 minus x. So by this is the beginning, this is the first year, this is the second year. Okay, so with this development of the formula, you can see this one for the third year, you will get this one. So by understanding the pattern above, we can obtain the formula for calculating debt after 20 equal yearly installment. So this one is a continuous happen. You look into this formula, look at the power here. Okay, look at the power here, look at the power here. Since there are 20 years, so we're going to substitute the power here into 20, and then you're getting to see that it's getting less and less and less. Finally, we conclude that S20 of a geometric series with A equal to 1, R equal to 1.05, and N equal to 20. So from this example here, you need to know that this will be the formula that you generate for 20 equal years installment. Okay, so from this one, we can summarize it into this formula. which is this one is 1.0520, 5,000 minus x, and then 1.05 or 20 over 1.05 minus 1. So approximately is each month need to pay 401. Okay, why we use this formula? Because this formula is actually derived from the formula that we have learned before. Okay, so this part is actually the r power of n minus 1. Okay, r power of n minus 1. All right, so as you see from here, why we use this formula, the one that at the front, because the r here is greater than 1. So we prefer to use this formula. Okay, so the final answer is 401. Okay, so this is the one that we get from, where do we get this one? We get this one from here, this one from here. Okay, right? Right, so give yourself some time to look into this formula. Okay, especially question type like problem solving question like this, you need to really generate your own formula based on the condition here, but also we adapt and adopt the formula that we learned before. Okay, all right, so we move on to exercise number 7. A, find the number of months it takes to repay a debt of 39,750 by monthly installments. The first installment being is 60 ringgit and the amount increasing by 30 ringgit each month after the first payment. Okay. All right. So you see this one, the debt is this amount of money. Monthly installment need to pay. And then first installment is 60, increasing 30 ringgit each month after the first payment. Followed by Steven saved RM 500 at the beginning of each year. He received an interest of 3% each year. Find the total amount of saving include the investment after 20 years. Okay, so I give you some time to try this question. Okay, if you want to try it first before you see the solution, you can pause this video first. You can pause the video. Okay, after you try, you can see what is the solution for 7A. Okay, by looking into 7A, we can always write out our sequence first. Okay, get 60, 90, 120. You can see the sequence and you find out the first value is the A is 60, the R is the 30. Okay, R is 30, and then we're not sure what is the number of term. So we can put into this formula the total amount of money and then put this formula, and then we will use this one factorization to find the answer. Okay, so as you see from here, this one was selected, this one is rejected, so it will be N50. So they need to took how long? Okay, so as for this question, back to here, so find the number of months. It will take 50 months to pay all, repay all money, okay, all the debt. As for question B, okay, as for question B, we come back to here, okay, find the total amount of saving including the interest after 20 years. So you can see first here is 500 plus, this one is the 0.3 is 0.03 times 500. So what is this? This one is the amount of money that he received including his interest. Okay, look into this one. This one is the principal. We call it principal because this is the money that you save for the beginning of the year. And then this one is the interest. So we call it principal. This one is interest. So the amount that we get here is the total saving that after both total principal and interest. But after that, on the second year, this money, okay, this thing is carried forward here. Add on 500 again and then you continue to get your why this one? Because 500 is your the year one saving. This one is your interest. So this one is your principal, your interest. So conclusion, this part is your year one, and then this part is your second year interest, okay, interest. So in this interest, they should include this one already. You can see repetition happen here. Okay, these two is the same. So you can see now this one is 515 plus 530.45 equal to 1045.45. So why this thing happen as in beginning of year, and then okay, he received for each year and the find the total amount saving including the interest rate after 20 years. So actually he's keep adding money, keep adding money, keep adding money, and so on. Okay, so this one. After 20 years, you will get this amount of money. The idea of this one is different from what you learned before this in secondary school, as in because this one 500 ringgit for year 1, year 2, year 3, year 4, and so on until year 20, they keep adding money 500, 500, 500 for continuously 20 years. Okay, continuous. At the same time, apart from this one, they also add in interest. Okay, add in interest. So you look into this, the difference between this question that the question that you ever learned in secondary school is a bit different. Okay, so that's why the formula look like this. So let me explain further on this formula. This one is the principal. This one is the R, the red. Okay, the first year money. So actually this one represent 515. And then this one is 1 times 1.0320 minus 1. This one is your R. This one is your R. R at the front because your R is more than 1. So total up after you keep calculator, you will get this answer 13838.24. Okay, so this one is a question for 4.4. Okay, you can keep trying to answer, practice on this type of walking step. Okay, fully master the idea of this formula is very, very important. Okay, so we move forward to 4.5, binomial expansion. Okay, binomial expansion. So by this learning outcome, at the end of this unit, students should be able to expand a plus b to the power of n, where n is a positive integer, while a plus b power of n where n is not a positive integer. Okay, so let's see here. In general, an expression such as a plus b, which consists of two terms, is called a binomial expression. So a plus b, two term, is called a bi. Bi means two. Okay, so a plus b to the power of n is called a binomial function. So you can see here, this is the binomial function. Okay, function. So the expansions of n plus b to the power of n as a power series in X will be discussed in this subtopic, expansion. Okay, so we look into this one. So let's see here. We used to learn this one, a plus b, power of 0. Anything that power of 0 is equal to 1. Okay, let us recall our prior knowledge. So a plus b to the power of 1, it will be a is same value as a plus b. But a plus b to the power of 2, okay, then will become a to the power of 2 plus 2ab plus b squared. So let us recall, it's actually a plus b, and then this one you multiply and then multiply, you get this answer. This process we carry forward to be like this and like this. From this observation here, you will see it look like a triangle like this. Okay, the power of the variable a decreases as the power b increases. So these sentences actually mean the a, you can see from here, a power of 3, a power of 2, a power 1. Okay, 4, 3, 2, 1 for a. for the yellow color one A. But when A is decreased, and we move on to see how about the B. B is increased as in power. You look at the power here, increase. Okay, all right. So this one is actually power of 1, but with default, so we need to write 1 here. The sum of the power of each term is the same as the power of n. Okay, the sum is the same. So let's see here. So actually, this idea is from Pascal triangle. Okay, so you can see here, all 1, 1, 1, 1, 1, all 1, 1, 1, 1. Okay, let us revise what is Pascal triangle, as in the top two number add together will get this this answer. To let's say 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, 2 plus 1 is equal to 3, 1 plus 3 is equal to 4. Okay, so 3 plus 3 equal to 6, 3 plus 1 equal to 4, and so on. Okay, let us, if you want to continue this one, here still will be the 1, here and here become 5, here become 10, here become 10, 5, and 1. Okay, and we continue. Okay, each row begins and ends with 1. The other coefficient in a particular row are obtained by adding the two coefficients just above the preceding row. Okay, coefficient above means that these two above will get this 6 answer. Okay, so all right, so this is a row 1, 2, 3, 4, 5. Okay, so those row 5 can be found from row 4. So Pascal triangle with a different notation. Now we put this one like this: 0, 0, okay, 1, 0, 1, 1, and so on. Okay, how we look into this one as if n choose R, okay, represent the element in n row and the R column of the rectangle. Okay, n row, okay, and the R column. So you see this one is row 1, okay, okay, row 1, row 2, row 3, okay, as this one column, okay, you can see from here the column, the column, the column here, 1, 1, 1, okay, here also 1, 1, 1. All right, so you can look into this situation. Okay, left here, positive here, positive. This is the row. This is the column. Okay, all right. Okay, all right. We move on to the formula here. Based on the understanding from here, you can see from here. All right, 1, 1, 2, 2. Okay, 3, 3. Okay. So come back to here. The binomial expansion a plus b to the power of n, where n is a positive integer, is as follows. Okay, this is a formula. So you can see from here, a plus b to the power of n. So this one is the first one. A, first term, power of n. Then this n, you put here, 1. Then n minus 1. And then n2, and then continue n3, n4, n5, n6 until nr. Okay, so the relationship between here is n minus 1, n minus 2, n minus 3, n minus 4, and so on. Okay, all right, and then this one b, b1, b2, b3, b4, b5. Right, so normally this one, the n will be a bigger value, and then come to the end is a smaller value. And then as for b, the power is getting increasing as we mentioned just now in the definition. So let's say a is equal to 1. So 1 and b. So you can see here 1. This one is 1 at n here from here, and then 1 is from here. This one 1. Okay. All right. Okay. So this one is 2 and so on. So this one is the factorial concept that you ever learned before this. Okay, so let's see, try to put this one in the real life situation like this, in the mathematic number example first. Mathematic example first. You can see expand this one 2x plus y to the power of 4 and 1 minus 6x to the power of 5. You can see from here, let us identify what is the A value. The A value is this one, which is 2x. The B value is y, which is this one. N is equal to 4. All right. So now the pattern look like this. This one is your 1. Okay, 1, 4, 6, 4, 1. Okay. So this one is why 1, 4, 6, 4, 1. Okay, back to here. Back to here. Here. 1, 4, 6, 4, 1. Why we use this row? Because this one is belong to row 4. Why row 4? Because see, here is 4. That's why it's 1, 4, 6, 4, 1. Okay, so after that, you can get your B is here. You look into this one, your B is Y. Okay, this one A. So this one start with A4, A3, A2, A1, A0. So you can see the A value here is getting less. So let me highlight the A value here. So this one is A4, A3, A2, A1, and A0. That's why it's not mentioned here, become 1. Okay, how about B value? B, okay, B0, B1, B2, B3, B4, B. So after that, after you put it into this formula, then you start to multiply. Example, this one, 2 to the power of 4 is 16. 16 times 1 is 16. 16. And then 2 to the power of 3 is 8. 8 times 4 is 32. And then 2 to the power of 2, 4 times 6 is 24. Okay, 2 to the power of 1 is 2 times 4 is equal to 8. And then 1 here. So this is the answer for question A. Okay, now you can see this is the fifth row. Okay, fifth row already. So you can see 1, 5, 10, 10, 5, 1. Okay, we go back to ours before this, the slide. This one, see? If the power of 5 is 1, 5, 10, 10, 5, 1. Okay, so we come back to here. Let us verify. Yes, 1, 5, 10, 10, 5, 1. Okay, so now this one is your A, this one is your A, this one is your B. Okay, so let's see. I repeat one more time. Okay, this one is your A, is your 1. Okay, so your A, 5, A4, A3, A2, A1. As for your B, negative 6, this one is B0. So B1, B2, B3, B4, B5. After we get this done, we start to multiply this amount together. Okay, so let's see this one, 1 times so the 1 of 5 is 1. And then this one, negative 6 times 5 is negative 30. Okay, when you do this working set, be extra careful, especially the negative sign. Okay, all right. And then this one is 10 to the 10 times negative 6 power of square. So negative 36, positive 36, sorry, positive 36 become times 10 become is positive 360. Okay, be extra careful here also because negative 6 after power of 2, they will become positive 36 times 10 become 360. Okay, so same goes to here, the power of 3, negative 6 become negative 216 times 10, so it's negative 2160. And then so on, negative 6 to the power of 4 become positive, and then it's 6480, and negative 6 to the power of 5, and then become negative 776. Okay, so extra precaution when you do set this sign. Okay, all right. Okay, this one question B. Let's see. By using binomial expansion, expand x times x plus y to the power of 6. Okay, you can see from here, we just now 6, 0, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay, so this one you can see, it's first one 6, and then and so on. Okay, 6x to the power of 5, 15, 20, 15, 6, and 1. Okay, all right, okay, all right, okay. So this one actually is a row number 6. Okay, row number 6. Okay, so we move on. Okay, exercise number 8. We are also using the same method, but this one a bit tricky because we may involve some number like fraction like this, may involve number like this. Okay, so you have to be extra careful with this kind of fraction. Okay, so let's see here. Okay, so you get this one, 5, choose 0, you get 32. Okay, this one 80, this one 80, negative 40, 10, and negative 1. Okay, you can use the calculator by using the factorial to help you to find this answer. Okay, all right. So move on to this one, example at C. Also, extra careful with this one. There's a fraction like this. Okay, so put it into bracket. Okay, put it into bracket. Okay, so that you can get your answer in better presentation. Okay, right. So this is your answer for binomial expansion involving term like fraction. And then move on to binomial expansion that involve number like this. You can see the x power of square and minus 2y over x. So it will be look more as long as you present your answer in bracket and do it one by one, it will be no problem for you to get this final answer. Give yourself some time to solve this one. I'm sure you can master this idea. You can pause the video when you try this question until you get this answer as your solution. Okay, so let's see this one. The symbol as you see just now, NR is defined for integer R and N such that 0 is less than or equal to R or less than or equal to N. So N CR actually we read as N choose R is equal to N or factorial over R factorial N minus R to the power of 2 factorial of this one. Okay, so the formula to calculate this one term in the expansion is this one. Okay, why we study this one? Okay, let's see how we apply this concept. Okay, so as you see just now, find the second term and the fifth term of the following. So you can see from here, the A is equal to 2x. So this one is your A. Okay, and then this one is your B. Okay, this one is your N to the power of 4. So if you write like this, we pick T2. T2 only. You can see this part here is 4, 1. Why this one 4, 1? Based on this one, okay, you have to know that this one is the power of 4. So 4, 1 is you get multiply 2x4 minus 1, y1. Okay, y it will be like this. Back to this formula again. Back to the formula as mentioned just now. Okay, we compare this formula and this formula. Okay, 4 is n. 4n, so you substitute n here, and then your r is 1. Okay, r is 1. Okay, and then your 2x is your a value, your 4 minus 1. Okay, and then y is equal to 1. So that's why you get this answer is 32x3 power of y. To find T2, R is equal to 1. Alright. To find T5, R is equal to 4. It's getting one step lower. Okay. Alright. So just now T2 is this one. And then T5 for question A. Okay. 4 to the power of 4. Alright. And then you get your answer like this. So please bear in mind, this one is your N here. This N, this one is your R. Okay, always one less, okay, from the term. T5, and then this one, R is equal to 4. Is T2, R is equal to 1. So you will get this answer. So by using the same method, try to solve question B. Okay, T2, the R is 1. Okay, and then T5, the R is 4. And then this one, we are using factorial method to solve. Okay, how to press this one? You can use calculator to help you to get this one. Okay, and factorial, and then get this one. Okay, all right. So you get this answer. Okay, let's see example number 9. Find the fourth term of the expression. Okay, fourth term and 10th term. Okay, so as for the fourth term, as I mentioned just now, is a 4, you choose R equal to 3. So this one is 6, 3. Okay, 6, why 6? Because this one is 6. And then why this one is 3? Because this one T4. We look for term form is 3 here. Okay, after you find this answer, you multiply, you get this answer. Okay, this is question number A. Okay, all right. So this one about question for number B. And then this one is 15. And then they look for 10, term 10. For 15, you substitute here. This one, 9 is 10 minus 1, 9. And then you get the substitute accordingly. Okay, you get this answer. So this one, we can present the answer as in negative to the power of 12. Okay, power of 12. When n is not a positive integer, so what we're going to do? Okay, when n is not a positive integer, the expression is the same when a is equal to 1, except that the number of terms in the series will be infinite. Okay, so the series in convergence or the expression is valid when it's in between this value. Okay, all right. Let us have a look on this formula. 1 plus b bracket power of n. Okay, so this one you can see from here. This one 2 factorial, 3 factorial, and it will continue. Okay, it will continue. So let's see this idea in this example. Expand each of the following in ascending power of x up to and including the term in x to the power of 3. State also the interval in which the expansion is valid. Okay, so let's see this one. 1 plus 2x to the power of negative 1. Okay, negative 1. And then this one, 1 minus 4x. 1 minus 4x, we want to convert, this actually can become 1 minus 4x bracket to the power of 1 over 2. Okay, so let's see how we're going to do as in. So bring this formula here. Okay, b is 2x, n is negative 1. Okay, this one is your b, this one is a negative 1. So you can put this one into the formula. Example, 1 is the formula plus nb. N is the negative 1 times 2x. So this one is your n, this one is your b. Okay, and then we'll put into this formula and continue, and we'll get this answer. Apart from this one, we also need to do the expansion is valid by, you take the b here, b, you bring it here. B is equal to 2x. So once this one move here, move both sides, okay? So, or we can say equalize it. We equalize it, it will become negative 1 over 2x less than 1 over 2. So this one is invalid if and only if in this range, okay? In this range, huh? Okay, so you must write your answer, this one and this one, as you can see from here. When this one, okay, so negative 1 over 2. So in this question, they have two phases. Phase 1, you have to find this. Phase 2, you have to find this validity, okay? So next one, continue, also same. We put, this one is B, this one is your N. You put into your formula, okay? And then you will get this answer. After that, you need to show your validity by doing this one. Negative 4 equalize both sides. Okay, now you can see something special happen here. Because this one is negative, to equalize, they will change the sign of this one. Okay, So after change the sign, then we can rewrite it as in negative 1 over 4 right here, and then 1 here. We put the smaller value on the left-hand side and the bigger value on the right-hand side. Okay, so let's see. More practice. Okay, you try to do this one. 1 plus x. So this one is your b. This one is your n. Okay, this one special case. Why? Because it's 1 over cert 1 minus x. You need to convert it first because before you start to find the first 4 term in expression for the following function ascending power. Okay, so in this question, they ask you to find the first 4 term and state the value of x, which is the validity. Okay? All right, you try first. Okay, you can pause this video to try. Okay, so if you're done, you can move on to check on the solution. So first one, the b is b is x, n is equal to 1 over 4. Okay, put into the formula, you get this answer. And then the expansion as b is equal to x. So negative 1 and 1. So you will write your answer in this format. You get this and then you get this. Okay. As we continue to move on to next question. This one is, okay, 1 over 1 minus x bracket 1 over 2. Since this one is a fraction, we have to change it into this format, 1x negative is come from this fraction, 1 over 2. So this negative 1 over 2, then this one is your b, the whole entire is a b, and then this one is your n. So you can put into formula and then get this answer. Is invalid. This one is only valid when negative x. Okay, this happened again. You can see the formula here have negative. Then if you want to remove it, it will become like this. So we write again into this format. Okay. All right. You need to show the steps. Okay. Now we try to use this one in this condition. Given the binomial expansion of this in ascending power of x to the series of this one, by substituting x is equal to 1 over 100 into the series, evaluate cert2 correct to 5 decimal places. Okay, so we put this down. This one is your b, this one is your n. Okay, put into the formula. Okay, all right, so here we go. Back to here again. Okay, this one is 1 minus 1 over 100 minus this value again. You can see here is 49 over 50 bracket to the power of 1 over 2. You will get this value. Okay, I'll let you observe this one. Okay. All right. So cert 49 over cert 50, you get this value. This one becomes 7. This one becomes 5. And then you move these two things over here, you get 1.414121. Okay, so this formula is actually quite special, okay, by using this one. Okay, all right, so by substituting x equal to 1 over 100 to the series, so you need to substitute into the series. After you substitute, okay, so you can see here, you get this value. Okay, you try this question. You try the question. This one is more challenging because this one is a problem solving question. Okay, all right. Okay, you can see this one is in 1.4142 in a long decimal. Okay, how many decimal they want? 5 decimal places. Okay, 5 decimal places. Okay, I always advise my student to try to master, try to revise, keep trying to see which working step that you miss out when you do this one. If you can't do until here, never mind. You can start from the beginning here. You practice one to write out this working step first. Slowly we'll construct how to slowly walk down here, write down here, and move on, move on. Okay, all right. So that's all for 4.5 and 4.5 subtopic. So thank you for watching, and for this topic, or overall this topic, it's just like this quote. Success is like a sequence. Each small step adds up, and together they form a powerful series of achievements. So some of the students may find this topic is challenging. You just take each subtopic as a sequence for you. You try to catch up, try to study, try to find out how to solve it. Source for any kind of possible method just to master the idea of sequence and series. But one day, I believe that you can link and add up all together, become a powerful series, and then you can master this topic. All the best. I wish you all the best, and thank you for watching. Bye.